Hi everybody. I just want to follow up on today's lesson on substitution. We've been working for a day or two on this idea specifically, although we've actually been using substitution in many of the word problems that we've been looking at so far this year. So here we are looking officially at substitution in the sense of having two variables and two equations. If you're curious, this topic is covered in detail in Chapter 9, Section 2 of your book. We're using it now in order to help us with word problems. Okay, so big things that I want you to walk away with are some vocabulary. These are things that we didn't talk about specifically in class, so I want to give them to you now. We've got systems of equations. So, whenever I have multiple equations put together in one problem, I call it a system. What you'll notice is that for this example, I've got two different variables, A and B, and I've got two different equations here. The rule of thumb is, or the rule is, that I need to have as many equations as I have variables. So two variables, two equations. If I have three variables, I need three equations, and so on. The next thing that I need you to remember is this word coefficient. Coefficient means the number that's multiplied by a variable. So in these three expressions or terms, which I pulled from these equations here, I have a coefficient of 3, coefficient of 2, coefficient of 1 here, and also a coefficient of 1 here. The last thing that we need to talk about is solution. So here we've got answers. We're going to solve this system for answers. And we're going to put it in this form here, right? It's going to be a coordinate pair where the first value is x and the second value is y. In other words, once I solve this system, I'm going to get a equals -4 and b equals -3. All right, so now let's look a little bit closer at how all of this works. So I'm pulling out this example. Got through this system of equations is 3a equals 2b minus 6, and the other equation a equals b minus 1. All right, this here, this value, b minus 1, is equivalent to the value of a, right? That's what the equal sign means. So in the other equation, this is important, in the other equation, where I see a, I'm going to instead write b minus 1. So using a little color coding here, I rewrote the equation, this first equation here in white, but rather than writing a, I'm going to write b minus 1, which is what a equals here. Okay? In class, this is where we talked about flipping index cards over with values. We've also used this color coding technique before. For some of you, this is as far as we got in class. I just simply wanted you to practice substituting one variable expression for another variable expression. I'd like to work the rest of this problem out for you, though. The next thing that I would do is I would distribute this 3 into both terms there. So I'd have 3b minus 3 equals 2b minus 6. Okay, so what you'll notice is that I distributed the 3 into both terms here. So I have 3b minus 3, and then the other side of the equation didn't change. All right, so here you'll see that I subtracted 3 from both sides of the equation in order to cancel the -3 here. Sorry, I subtracted a -3, which makes it positive. Adding 3, cancel, bring the 3b down, 2b comes down, and then -6 plus 3 is -3. I do the same thing here. I want to move the variables over to the left side. Subtract 2b from both sides leaves me with 1b on the left and a -3 on the right, so b equals -3. Now what's important to remember is that because I have two variables in the beginning, I'm going to have two answers at the end. You'll remember back to the first slide that I had an ordered pair. Two numbers that were my solution. Right now, I've only got one part of that solution. I have what b equals. Now, in order to figure out what a equals, I'm going to take this value, plug it back in up here for b, and determine a. All right, so one of the things that I get asked a lot, or I even sometimes think about myself, is how do I choose which of these two equations to use in order to figure out a? The answer is, at this point, it doesn't matter that much. We'll get the answer either way, whether we plug in -3 here for b or -3 here. I like to make my life as easy as possible. So this equation, just at a first glance, looks like it's the easiest to use. I don't have a coefficient in front of each of my variables. Also, I already have a solved for. So a equals b minus 1. So whatever I plug in for b here is going to give me a. Now you'll see that I've made this substitution here. I've taken the value of b and I've plugged in here, and actually I found a mistake. It's actually a -3, so I'm going to change this to a -3. So I've got this equation, plugged in a -3, going to simplify both sides, a equals -4. So now I've got two answers, a equals -4, b equals -3. Both variables have a solution, which means that both equations have been solved. Okay, so as we just saw in the previous slide, a equals -4, b equals -3. A way that I can write this solution is here. Remember back to when you've studied graphs, or maybe in Mr. Dreyfus's class when you're studying slope, you've got this ordered pair in parentheses. The first value is going to be your independent variable, second value dependent. In our case, we named the independent variable a and the dependent b. So -4 and -3 is a different representation. We call it notation, a different notation of this answer. Now the very last step that I want to show you, and there are a few of you who are looking at this in class, is checking your work. So now that I've got this solution, I'm going to take each of the original equations, plug in -4 where a shows up, plug in -3 where b shows up, and then I'm going to simplify both sides, make sure that my equation is true. If the equations are true, that means that my solution set, the answers for a and b, work for this system of equations.